Okay, so we're doing test number 7, and this is question number 9. Question 7 and 8, we were working with frequency, which was a formula we needed to memorize. In question number 9, we're working with energy. If the energy of light emitted from an atom is 2.3 times 10 to the negative 15 joules, what is its wavelength? Okay, so energy, we're told, is Planck's constant times frequency. And frequency, we know, as we worked with in 7 and 8 questions, is the speed of light divided by the wavelength. So first we have to figure out the frequency, and then we'll be able to figure out the wavelength. Okay? So using this, I'm going to say frequency is going to be energy divided by Planck's constant. All right. So going back to what we have, say energy, 2.3 times 10 to the negative 15 joules, divided by Planck's constant, which is given us at the top of the page on the test as this constant, H, 6.63 times 10 to the negative 34 joules per hertz. Okay, so I'm going to use my smarts to say this becomes canceled, and 1 over 1 per hertz just becomes hertz. Okay, so whatever I get will be in the units of hertz, which is good. That's what I want. So let's clear this. Sorry, 2.3 divided by 6.63. Okay. So that gives me 0.347 times 10 to the negative 15 minus negative 34. It's plus positive. So gives me positive 19. I have to move this over to give me the proper notation, and I can only have 2 to make that 3.5 times 10 to the 19 to the 18 hertz. Okay, so that's step 1. Everybody tracking, I hope? Okay, so now using that information, the answer to the frequency, I can go back and find out the wavelength. So the wavelength, erase these calculations. Let's rearrange my formula. Frequency is the speed of light divided by the wavelength. So if I say frequency times the wavelength equals the speed of light, the wavelength equals speed of light divided by frequency. All right, so the speed of light, so I'm going to say the wavelength is 3.0 times, this again is given to us at the top of the test, 3.0 times 10 to the 8th meters per second, divided by, divided by the frequency. This will give me the wavelength. That's what I want. The frequency is 3.5 times 10 to the 18 hertz. And hertz, as you remember, is 1 per second. So I'm going to use that unit so that I can cancel my units here. So that'll be meters, which is, of course, what I want. Let me use my calculator to do these calculations. 3 divided by 3.5. 8.8571. Okay, and it's times 10 to the 8th minus 18. Okay, so that'll give me I want to use two significant digits, so I'm going to say 8.6. So 8 minus 18 equals negative 10. Move that over, times 10, the negative 11, meters. So the wavelength let's just check to make sure we answered the question. If the energy of light emitted from an atom is 2.3 times 10 to the negative 15 joules, what is its wavelength? Its wavelength is 8.6 times 10 to the negative 11th meters. Okay, now we're looking at number 10. Which is the heaviest? A neutron, a proton, or an electron? Okay, well, obviously the electron is the smallest, and the neutron is the heaviest of the three. Okay. And they couldn't discover it for a while. They couldn't figure out what was missing from there because it didn't have an electrical charge. Number 11. Since an atom is emitting light, what are its electrons doing? And so if it's emitting light, it's sending out energy, okay, which means it's losing energy. Its electrons are going from, so if it's losing energy, right, the electrons live in energy orbitals, right? And when they have high energy, they can be in the higher energy orbitals. Since it's losing energy, they have to be going from higher to lower energy orbitals, okay? Number 12, order the three orbital shapes we have studied in terms of increasing energy. Well, the three orbital shapes we have studied are S, P, and D. And that's the order we've studied them in, okay? So the S ones are the lowest energy orbitals. P ones are the next highest, and the D are the highest energy of the orbitals that we have studied. Okay, I'm going to pause this video here and come back with the final video for 13, 14, and 15.